All right, so here we are on the fourth page of our AMC review, and this problem asks us to graph this function. It's important to notice that it is an exponentially decreasing function. If we don't notice that, then we might misplace our y-axis and not be able to see things quite as well. And the other thing to notice is that when we graph this function m of x, we're going to take that previous function and we're going to subtract 4 from it. And so this is going to be, so this one is going to be coming down like this, and this one is going to be coming up like that, because the -2 means that it's going to be reflecting. So we have to think about those things when we're thinking about where we want to put our x and y axes. So here I'm going to put uh, my y-axis just about right here in the middle. And I'm going to put my x-axis pretty close to the middle as well, because I have to do things on both sides of the x-axis and the y-axis. And as I think about how I want to uh, do this, I'm going to go by every 4 is going to be 1 unit on my x-axis. And I'll just go by ones again here. And that's going to be 5. And one of the reasons I want to do this is to show you that you got to do this in order for your graphs to turn out looking right. And so I'm taking the time to do this along with you because I want my graphs to look right. Okay, so the first one we're going to graph is the 1/3 x. H of x is 1/3 x. So right there. And because the asymptote is the k value is 0, I can put right in here on the x-axis. That's my y equals 0. And my a value is 1. So right there is 1. And then because my multiplier is 1/3, as I move to the right 1 unit, I multiply my 1 by 1/3, and it gets down there really close to the x-axis super fast. And so as we move 1 unit to the left, we're going to take our y value there of 1 and multiply by 3. So we're going to have a point at -1, +3. And then we can do the same, moving 1 more unit to the left. We have a y value here of 3. So when we move 1 to the left, we're going to have a y value of 9. It's going to go right there. And so that is our graph of the equation. And then it's going to grow super fast. So that is h of x, which is equal is 1/3 to the x. Oh, and my y-intercept here is 0, 1. And that is all that it asks us to show. So the next one here is m of x, which is -2 times h of x minus 4. So this -2 turns the graph upside down and stretches it by a factor of 2. And this -4 moves my asymptote down 4. So I can just take my asymptote and I know where it's going to be. And that's a good place to start the graphing here, is right here at, did I do my axes wrong? 1, 2, 3, I did those wrong. All right, so I'm going to have to fix that before I do anything else. Sorry about that. So let's see. Glad I noticed that. I said that it was important to do it. It's important to get it done correctly too. If you don't do it right, then doing it doesn't help much. So here's my asymptote for that m of x, and it is at y equals -4. So again, the 2 here stretches the graph vertically by a factor of 2. So we can compare the distance each point is away from the asymptote, and then we're going to stretch it down. So because this is a distance of 1, down here it's going to be a distance of 2 away because we're stretching it away from the asymptote. Now, because this is a distance of 3, we're going to have a distance of 6 down here. And that's going to put us right there. Now, let's see. This is a distance of 9, and so we would have a distance of 18, and we're going to go off the graph there. So here we have a distance of 1/3. So we're going to double that, and it's going to be a distance of 2/3. So it's not going to approach the asymptote quite as fast, but it's still going to get there pretty darn quickly. All right, so that's what our graph's going to look like. Just like that. And here our y-intercept is going to be 0, -6. Identify the domain and range. I'm only going to do one notation for each this time. So the domain is x such that, well, it goes from -infinity to +infinity, so x is in the real numbers. It can be any real number. The range is y such that y is also in the real numbers, but y is restricted to numbers greater than 0. And it can't be equal to because that's the asymptote, and it can never equal the asymptote. On the other one, the domain is x such that x is in the real numbers. It can be any real number. And the range is y such that y is also in the real numbers, and y must be less than -4. All right? So that is the domain and range of those two functions. All right, so here's a challenge problem. Suppose it's going to be challenging. The number of lily pads on a pond is increasing exponentially, doubling every 24 hours. There are initially 24 lily pads on the pond, and after 24 days, the pond is halfway covered in lily pads. When will the pond be fully covered? So, if you think about this, there are initially 24 lily pads on the pond, and it's doubling every 24 hours. Well, 24 hours is one day. So the way we can think about that is that the initial value is 24. There are initially 24, and it's doubling every day. So x is the number of days. No, that isn't the right way to think about it. All right, so let's make a table. All right, so on day 0, there are 24 lily pads. And we know that on day 20, after 24 days, it's half covered. So however many that is, that'll be some number. it'll be half covered. And so the question is, when will it be fully covered? So after how many more days, it'll be some number, and it'll be fully covered. This is a tough problem. All right. So y is equal to 24 has to be the start. And we know that after 20, so it's multiplying by 2 every day. It's doubling every 24 hours. So this was the right way to think about it. After 24 days, how many will there be? Well, it's going to be a lot. So let's get a calculator out here, and I'll bring it over. So 24 times 2 to the 24th power. I don't even know. Yeah, that's pretty big. All right, so let's see. There's 100,000, 400 million, 402,653,184 lily pads. And that's half covered. So what we want to know is if we take that 402 and we plug it in for y, we have to double it and plug that in for y. That'll be fully covered, and then we'll solve for x. All right, so we're going to take that value, we're going to multiply it by 2. Oh, this is tricky. It doubles every day. So if it's half covered at the end of day 24, it'll double the next day and it'll be fully covered. So we didn't even have to do this. So it's going to be fully covered after day 25. Oh, it was a tricky question. No wonder it was a challenge. It's doubling every day. If it's half covered after 24, it'll be fully covered after 25. That was a good problem. I like it. All right, that is the end of the review. I hope it helped. Ask some questions, get some help before the test. Good luck, everybody.